Good morning and welcome to this next lecture on sound and structural vibration. Last time we ended up here. We were looking at contours in the complex plane for our integral, and one of the ways for defining a continuous branch for this gamma function was using this particular cut over here. So there is a vertical cut from K0 that goes off to infinity this way, and one from minus K0 that goes off to infinity downward, and the angular definition here is theta and here is phi. Okay, and theta ranges from pi by 2 to 5 pi by 2. Phi ranges from 3 pi by 2 to 7 pi by 2. Okay, so I'll just repeat a few points. So here this is a vertical cut here, there's a vertical cut here. So if I look at theta phi values, okay, so phi value here is pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, that's twice pi, and theta here is equal to 3 pi by 2, 4 pi, twice pi, both twice pi here. Okay, just on the top. And below, just below, we have same values. Okay, theta is equal to twice pi, phi is equal to twice pi. Now if we just cross this line, if we cross this line, okay, now here theta is 2 pi by 2, which is pi, and phi is again 2 pi. Okay, so I get the summation 3 pi, and I have a square root, so I get e to the power I 3 pi by 2, which is negative I. Okay, and what did I say last time? I said gamma given by this entity for real values of k, when magnitude of k is greater than k0, I should get a real positive number. So this is the region where magnitude of k is greater than k0 and k is real. So I get e to the power I twice pi plus twice pi by 2, which is e to the power I twice pi, which is plus 1. So this satisfies the criterion. Similarly, when I am below k0, okay, for real values of k0, I mean real values of k such that magnitude k is less than k0, I should get negative imaginary. Gamma should be imaginary with a negative value. So you can see I am getting a minus I in this region. Okay, the same thing will happen if you calculate here and here. Okay, so here you will get a real value positive, here you will get a negative imaginary value. So this is a valid cut. Okay, so how will the integral look like? I will just show you. So we have this line over here, and I have a cut going from k0, I have a cut going negative from minus k0. Okay, so I want the real line integral. My v of x is a real line integral of the form minus infinity to infinity some function dk, right. So it's a real line integral. So I will come from minus infinity above the real line, cross over here, go below. So this entire real line I have, okay, and that integral we don't touch using principles of complex variables, right. We compute using residues and other indirect contours. So now I go to infinity and take an arc at infinity. I come to this line which is a branch cut. I cannot cross it, so I come down till the real axis, go around this k0, again go up and go off at infinity as an arc and join at minus infinity. That's my contour. So this is my closed contour. And for causality, again I repeat, for causality, because my phi is a e to the power minus gamma y, okay, with a time dependence of minus I omega t. If gamma is real, for k values on the real axis, then gamma must be positive real. Then this term decays with y, else it will blow up with y. Similarly, if gamma is imaginary, when k is on the real axis, then gamma must be negative imaginary. Then I will have phi as an a e to the power of minus I omega t plus I something y, which is a propagating wave in y direction. It goes upwards from the plate, it goes to infinity. So these two are must be respected, okay. So when we do these contour integrals, two things become important. One is that the gamma that you define must be continuous, a continuous function without jumps, continuous branch without jumps, okay. The other is, this is one. The other is causality. Both are separately satisfied or separately important. So this is the causality condition. This is the causality condition. Okay. So we will use this contour later to compute our v of x. Okay. And then of course there will be singularities. There will be singularities in the inside the contour, and we have to compute residues. Okay. So that singularities is another big topic, we will see. Now just so that I churn your mind, I will use another contour, means another cut, okay. So let us see if we can understand that. This is my complex plane, okay, and and I have gamma. I have my gamma, which is square root of k square minus k0 squared. So this is my k0, this is my minus k0, and here let's say is my k. So this is my k minus k0, and this is my k plus k0 vector or phasor. This again is my theta, and this, I'm sorry, this is my phi, this is my phi, and this is my theta. Okay. Now phi, I will keep it again going from 0 to 2 pi, and theta going from minus pi to pi. So if we now look at values here, okay, phi is 0, theta is 0. Here phi is pi, theta is 0. Similarly here phi is pi, theta is 0. Here phi is pi, theta is pi. Okay. Here phi is pi, theta is minus pi. Okay, because theta moves from minus pi to pi this way, and phi goes from 0 to twice pi this way. Again here my phi is equal to pi, theta equal to 0. Here also phi equal to pi, theta equal to 0. Here phi equal to twice pi, theta equal to 0. Okay. Now if I look at this e to the power I phi plus theta by 2 factor, I get e to the power of I0, which is 1. I get e to the power I pi, which is minus 1. Okay. Now we come here. Here let's see. Here I get e to the power I pi by 2. Okay. Here also I get e to the power of I pi by 2. Here e to the power I pi. Here e to the power of I0, which is a minus 1 and a 1. Okay. Now what did we say here? When k is on the real axis, okay, and gamma is going to be real, that means magnitude of k is greater than k0. Okay. So here basically in this region I should have gamma positive. Okay. That means e to the power I0 must be a positive number. So on the top it satisfies, but on the bottom it is negative. Okay. So this is not correct. In this region the bottom is not correct, and this is discontinuous here, which is not good. Okay. Because our main concern is always this real line integral, mind you. We are always interested in this real line integral, which we have to compute for inverting the transform. Okay, everything else that comes is incidental. So when I am here, I cannot be discontinuous. Okay, on the top I have one value, bottom one value, no. Okay, so this is not okay first of all. Now when I move down, when I go below k0, when my k goes below k0, k is below k0, okay, and gamma is going to be imaginary, it should be negative imaginary. Okay, and if you see here, it is e to the power I pi by 2, which is I, which is positive imaginary, so it's also not good. And below again e to the power I pi by 2, that is also not good. Okay, so what should we do? Similarly here, similarly on the left side, okay, here on the top I get I pi by 2, which is I, here lower part I get e to the power I pi by 2, which is again I. Here also k magnitude is less than k0. Okay, that's one thing. Then on the left over here, on the top I have -1, on the lower side +1. Again I have a discontinuity across this line, which is my main line that I want to move through. Okay, so here also I am not okay sign wise. So several places I am not okay. I am not okay here, 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 I am not okay here and here. Okay, so what we do is we multiply this region by -1, okay, and we multiply this region by -1. So what happens when I multiply by -1? That means the fourth quadrant is multiplied by -1. Okay, I get a +1 here, therefore I am continuous with this part. So this part beyond k0 has become continuous. Okay, and let us see, here I had e to the power I pi by 2, I become, this is plus I, it will become minus I. So imaginary should be negative, I am also okay here. Okay, and in this part it does not matter what I do. Okay, whatever is the result is the result, we will leave it like that. Okay, because we are going to move on this contour. Okay, so that means what, now there is a discontinuity. From the top it's e to the power I pi by 2, from the lower side minus I pi by 2. So we create a discontinuity here. This line is discontinuous. Okay, now on the left similarly, on the top we will multiply by -1, second quadrant. So the second quadrant is multiplied, then what happens, e to the power I pi, which is -1, becomes +1, and I have +1 here anyway. So I am continuous here, I am continuous here. Okay, but here what happened, e to the power I pi by 2, which is I, now becomes -I. So imaginary negative, I am okay here, but from the bottom side it is +I still. So I have a discontinuity here. Okay, so what we now have essentially is we come, so let us see. So we come this k0 minus k0 real imaginary. Okay, here we multiply by -1, here we multiply by -1. Okay, so I begin my contour, and this is a discontinuity, and this is a discontinuity. Okay, what happened? This is a discontinuity. Okay, so we come from minus infinity, we get on to this cut over here. Okay, we cross over below, we get below the cut. Okay, then we jump off the cut, we go off to infinity. Okay, and we come all the way on an infinite contour. Okay, and there is a jump now between these two lines over here, so we can't cross that line, so we come down, we come straight down, go to the right, go around this, come back, cross over, go up, go over all the way on an arc of infinite radius back here and join up. Okay, so essentially, as long as my k is on the real line, okay, I use the causality relations. Okay, so that I respect the angles, and the other I respect causality. Okay, so when I'm in this quadrant, I will multiply whatever integrations come with a -1. Okay, and then I move on to the first quadrant, which I don't touch. I can't cross this because it's a discontinuity. I come down, I go again here. Okay, I'm not worried because the main part I want is below here. Okay, that is what maintains the cut over here. I go around, then I am below here. Here again I have to respect the causality. Then I go over here again, I have to respect the causality because there's a -1. Okay, then I go off to infinity, come down, and I join up. Okay, we will not be using this cut, so this is all we are going to see. Okay, essentially in contour integrations we don't touch this line at all. Okay, we don't touch the real line at all. It is indirectly computed, and therefore in the indirect computations, when you get the other portions of the curves, other integrals, the extra integrals that you get, okay, that is where you have to enforce your causality impositions. Okay, so by implication, I am coming from the left, I am getting onto this cut, coming down here, getting off the cut and going off, but I don't touch that integral anyway. So how are these causalities imposed? Okay, these causalities are imposed when I am, okay, here and here when I get back, right. I have portions of the cut where I get back here, I cross over here. Okay, so in these parts I implement the minus, in these parts I implement the negative. Okay, so I have a gamma 1 for example, I have a gamma 2 for example, I have gamma 3 portion for example, I have gamma 4 portion for example. Okay, so let me write it out. Let me write this out. So I have, let's say, the closed form integral okay for velocity, whatever it has, dk, k has become complex, that has what, the real line integral, real line, which I don't touch. So plus, let's call this the 1, let's call this the 2, okay, let's call this the 3 plus 3, there is a small circle, call it 4, there is a bottom line, call it 5, then this is vertical, call it 6, I go up, so that's 6, then I go off this arc with infinite radius, call it 7, okay. Those are equal to the twice pi I times the residue of the function at the singularities inside. So there are some singularities again, so I have to compute the residues. Okay, so now in the portion, in this portion, whatever was the number I forget, 1 2 3 4 5, in 5 and in 6, in 5 and in 6, okay, I had implement the negative, okay. So when I implement the negative in the 5 and the 6 portions, then what happens is, in the main integral, causality and the cut definitions are implemented. Okay, so we don't do anything to this, the cut definitions are implemented in the remaining portion, okay, and of course the singularities and residues. That's how the both angles and causality are maintained. Okay, the main idea I am trying to convey is that we don't touch this integral. So how do we respect the angles and the causality? By implementing that in the other portions, by implementing that in the other portions of the contour integral. That's how it's done. Okay, time is running out, so I will close the lecture here. We will continue from the next class. Thank you.